So there's the training session, which takes a lot of energy anyway.
Yeah.
And then also
inference is what we call it, when you actually talk to the thing. And you've got to think that you're going through this network a lot of times because it probably only produces 1 or 2 tokens at a time. And so it's not very efficient. And it's hugely expensive to do this. Once it's been trained and maybe cost you $100 million because it's a giant model, what Mixture of Experts does is it's trying to have different bits of a network focused on different tasks. But let's imagine you have a prompt here that comes in and you have a giant network that finally gives you your answer over here. And this has, let's say, 670 billion parameters in it. The problem is you don't know exactly which bit is solving which problem. So maybe you ask it a very specific maths question. What Mixture of Experts will do is have trained a specific part of this network, a much smaller part, to solve that problem for you. And so you basically have the early stages will route the question to different parts of the network and then only activate a small part of it, let's say 30 billion parameters, right, which is a huge, huge saving. So this sort of shaded area here will activate, and then that will produce your answer. You can develop systems using agents like this, where you have one that's trained to do this and one that's trained to do this, and you just ask the right one. And then I train a different network to solve a different problem, and I just ask the right one, as opposed to hoping that one model can do it. Okay. So that's much more efficient because you can distribute these different bits across a data center. Some of them can lie dormant when they're not being activated. It's much cheaper to do this. And so that's one of the reasons, I think, why DeepSeek's pricing is already coming in very, very low compared to the pricing of some of the other companies. Another thing that is being shown to work really well is, so you could have this giant model and you could only activate certain parts of it. That still requires quite a lot of infrastructure. But what if you had a much smaller model and you used this to teach it what to do, right? And that's another thing that's becoming really, really useful. And people are already taking these giant models and using them to train smaller models. So essentially, this is a process called distillation. And the idea is you take your 670 billion model, you ask it a bunch of questions in a certain field, and you use those answers to train a smaller model to do the exact same thing. And often it will work because actually a lot of the parameters weren't needed or were solving some other task. And so you can distill that problem solving into a small model. So you can get pretty decent performance from an 8 billion model, right, which will run on standard hardware.